Alright, this is now my third time doing this problem. I managed to delete it twice. Thankfully, it's an easy problem. This is just sort of our intro to momentum and impulse. So the TJ cheerleading squad is using an elastic cord to shoot this shirt into the stands of a football game. Takes so long to launch, and has a speed, launch speed of this. So, just to sort of draw a little picture of what we're talking about, here's the shirt. This is sort of before, and then afterwards, this is like the slingshot. So this is the slingshot here, and then the slingshot is like afterwards spent all of its, its energy, and you now have this shirt flying with a velocity of v. I'll call it v sub l. Okay, and the velocity here is 0. Okay, mass was given, and then this picture here was t times 0, and this picture here was time t equals delta t. So there are two ways to do this, but this is a momentum unit. This is sort of our momentum warm-up problem, so I'm going to do it with momentum. So momentum here is mass times velocity, and before, velocity is 0, so momentum is 0. And here, momentum is mass times velocity, and it's this launch velocity here, so m v sub l. Alright, so what is our, so this is, I'm going to call this momentum final, and this is momentum initial. Okay. So now what is our impulse? Impulse is just change momentum. So change anything, take the final value minus the initial value. So pf minus pi. So this is going to equal m times v sub l minus 0. So the impulse given is just m times launch velocity. So it's really just the final momentum is the impulse, because it started with 0 momentum, right? So now, what's our other definition for impulse? We want to find the average force on this thing over this time delta t. So impulse is average force times the time over which this force is applied, or the time over which this is the average. So we want to find the average force. So let's take f average, and we'll just divide everything by delta t. So this is impulse over delta t. And then the impulse we found up here, right, is m v sub l. This is going to be m v sub l over delta t. Okay, so that's our answer. And as I recall, we have mass was 0.5 kilograms. V sub l was 9 meters per second. And delta t was 0.1 seconds. So 0.5 divided by 0.1 is going to be 5, right? And then times 9 is 45. So this is equal to 45 kilograms, meters per second, and then per second. That's meters per second squared, which is, if you recall, kilogram meter per second squared is a newton. So this is all equal to 45 newtons. So that is your final answer for average force. Right. So let's type that in. But you know what? I know it's correct because I've done it 5 million times. That's correct for my numbers. Trust me on that. Now the other way to do this is, I'm going to just show you this real fast in purple. Feel free to skip ahead if you don't give a damn. So this is our average force here, is this, right? Is that, okay? So v sub l is also our change in velocity, right? Because we started with a velocity of 0, final velocity v sub l, so this is actually a change in velocity as well. So this right here is average force equals mass times change in velocity over change in time. Now, what is delta v over delta t? That's your average acceleration, right? So what this becomes is f average equals mass times acceleration average. So this is just f equals ma. So what this means is we could have taken, instead of doing it this momentum way, we could have taken the delta v we had, which we could find from 0 to v sub l, just v sub l, and the delta t we had, which was 0.1 seconds. So we could have actually found that average acceleration was 9 meters per second divided by 0.1 seconds equals 90 meters per second squared. And then when you multiply the 90 meters per second squared, which is this, times the mass, which is 0.5 kilograms, you would get 45 newtons. So there are two ways to do this problem, and this is just sort of an example. This is a good example of how momentum is really just another way to approach the same problems we could already do. But it's much more useful for certain kinds of problems, and much less useful for others, obviously. But it's good because it means we have two tools available to solve these problems.